please welcome the second speaker, Professor Visala from Aalto University. The screen is yours.
Can you see my presentation now?
Yes, we do.
Okay. I just noticed that I have quite a lot overlapping slides with the presentation of Roy, but I'm going to jump over them. So at first I will tell in general about automation in ships in order that people know what there is and what is the role of automation system. And then I will tell about, of course, I'm commenting this autonomous thing all the time. But then I'm going to do the research what we have done, and I have some items. But at first, something about automation in general, and these slides are from course Ship Systems, which is the course of Pentti Kujala in Marine Department, and my role there is speak about automation systems. And then I'm telling you also something about autonomy as well. Did it change the slide? Wait a moment, what's happening?
We still see the first.
Yep, okay, now it's changing, yes. Yeah. Okay, so here is in general about ship automation control systems, and actually that is the contents, but I'm jumping over so that there is more slides about autonomous ship and about the research what we have done. And okay, there is a lot of ships, and okay. Autonomy means that the system can sense, and then it can plan, and then it can act. That autonomous means that it can make autonomous decisions and act autonomous. So traditional automation is programmed, so it is doing as programmed. That is the difference. And actually, I don't like the term autonomous ship because, or actually, it should be okay. Something similar is unmanned ship. So that, but where few people can run a ship, for example, container ship is something, and maybe tanker and maybe short distance ferry as well. But most of ships are such that actually in order to operate them, there are people needed. So I think semi-autonomous systems are needed. And I like the term smart marine because that is general. It does not actually take any decision about how much people there is. There is a reasonable number of people, and the whole thing is working reasonable way. Okay, so this is a slide from ABB, and there are a lot of different kind of ship categories, and for each ship there is of course different kind of automation needed. And for example, if you have drilling ship, it must have very good dynamic positioning system in order to keep the same ship in the same position so the drilling is possible, and so on. So there are of course special requirements in ship type. And here are actually subsystems in ship typically. And okay, there is propulsion control. Actually, this might be ABB products already, some kind of functional products. And there is thruster drives control and so on. So there are a lot of subsystems in the ship, and when certain companies selling certain subsystem, it's usually selling the control system specific for that. So even if there is automation system, there are still for each subsystem their own control system. So that is the architecture. Okay, so and here is the view from Wärtsilä, and there are a lot of functions here. This is a bit different than in the previous slide, but if you think what is related to running or driving a ship, there is navigation and dynamic positioning system, and okay, bridge operators and radar is the most important instrument to sense what's there outside. Okay, those are related to running or driving the ship, and then there is of course this power distribution and actually propulsion system. Actually, it's not so here, but this division is a bit different. But you can see that there is a lot of different kind of functions, and for example, okay, in this kind of cruise ship, there is power plant, and it's the diesel engine current generator, and there is propulsion systems, of course, and control system for that. And Atsipuda, very very good example. And but there is also a lot of building automation because people are living there, and that kind of, so it is a small town in practice. So that kind of automation is also needed in a ship. But power management and that kind of things, they are very important. And here is still one. Actually, this is now the Valmet slide, and here are actually the application areas how actually functions of the ship can be divided. So that machine control and monitoring, there is currently diesel engine and it should be run, and it's actually running generator, generate electricity, and there is power management, how to do that in an effective way, and maybe there is some storage. Actually, currently there is not so much storage for electricity, but it's needed, for example, when the ship is going to ice. Okay, there are different kind of functions. I'm not going through everything, but this is important. And now we are coming to the, okay, there is also some about the regulations. So Roy referred also this already, and actually safety is the most important thing. And for safety, there are special regulations, and fire and flood are the most difficult cases, and there are special regulations, and of course those must be taken into account, and of course these must be changed if the level of autonomy is increased, or actually the way of operation is somehow changed. Okay, now I'm coming to the automation system part, and these slides are from Valmet, and Valmet has sold quite a lot actually automation systems which are integrating the separate functions of the ship together. And all automation is network, and here is actually the main network in the ship. And then there are operator stations, and of course there are other control rooms and so on. There is a bridge, of course, so that people in the bridge can see what's happening there in the ship. And then all kind of system, and then we are coming to the control part. So here is process controller. And what is important, that this is redundant, so there is reserve system as well, so that if something happens, there are critical functions which must be guaranteed, and that's why there is this kind of physical redundancy, so that things can be done, even if there is fire and that kind of thing. And okay, that kind of things. And what is important is that there is actually redundancy. For example, if fire situation comes, actually the ship can be still operated even in that kind of dangerous situation. So safety is the most important criteria. Okay, so this is the main automation system of the ship, and this is integrating all the functions together, but each sub-function or sub-module, they have their own control system. The Wärtsilä Diesel has their own control system, and the Agiports have own, and so on. So that, but this is the way how the whole ship is integrated together, so that the people there in the bridge can operate the ship and run it in a safe way. Okay, and here is more about the redundancy of the ship, so that the networks are redundant, and all critical things, so that if fire situation comes, the ship can be still actually operated in every condition. That is the goal, and safety is the most critical goal for the automation system as well. Okay, there is a lot of functions, but I'm jumping over so that we have enough time to actually discuss about autonomy and that kind of things. Okay. Here is one example in order to see how actually wide the systems are. So this is now the Harmony of the Seas cruise ship made by STX in France, but there is Valmet automation system, and there is more than 40,000 different input-output points in the automation system. So it is really big, and it's one of the biggest what Valmet has done. It's similar to the oil refinery in Norway, that is the similar as wide system, but there is a lot of automation, a lot of measurements, and a lot of controls in the automation system, a big ship. And actually you can see here that 28,000 are hardware directly from the automation system, but 40,000 are actually via those local control system for each subsystem. So they are data links to other actually subsystem control systems. Okay, but this is huge system. Okay, and of course, cyber security is very important. How to guarantee if there is so wide automation system, how actually guarantee cyber security, and actually those routers, they are actually the critical thing. And Valmet is cooperating with Cisco, and they have such a router network system that cyber security can be guaranteed in every condition. That must be so. Okay, and here is some slides about APP system. And APP is really big company. They're making also automation systems for ships as well. But this is now more related to actually maneuvering ship. So these are control devices to use the Archipods and propulsion system of the ship. And I could show similar slides about the architecture of automation system as I saw already in the case of Valmet system. And okay, I'm not going to details, but you can find actually same things. So in the lower level, there is intelligent devices and embedded controls, and then there is this control, upper control level. Of course, there is human-machine interfaces, so that people can operate the system. And here are typical APP Archipods, which are really efficient propulsion devices. Okay, and actually this is related to navigation of ship, and this is human-machine interface for actually those products what APP is actually offering for to the bridge, how to operate the ship in an effective way. Okay, but now I'm going to the autonomous system part, and actually Rolls-Royce was publishing quite a lot about these things. I'm using now actually slides from Rolls-Royce as somehow back material. I have added some, so that instead of speaking about autonomous ship, we should speak about semi-autonomous, because I believe also in the same way that there are still men or man needed or women needed, humans there in the ship to operate it. And then if it is unmanned, there is always someone who is responsible for the ship, so that remote captain. So it is remotely operated in any case. It cannot be fully autonomous, even it is unmanned, the ship itself. That's the point. And then actually, okay, this is now a slide of Rolls-Royce. Here is what is ship intelligence. Actually, okay, this first part, actually the essential functions to actually get ship driving autonomously, actually they are here, so that autonomous operations, so that perception is here, and planning activities, decision making, and that kind of things. But actually, let's look at those other boxes at first. So this health management is very important. It means the maintenance of all physical systems there is, and if the ship is unmanned, actually there is not any more people who are taking care of the machinery and servicing them all the time, and actually machines need maintenance. And actually it means that if there are no people in the ship which are making the maintenance in the ship, then when the ship is going to the harbor, then actually those operations related to maintenance and service must be done there. So it is actually changing the way how service is done. Okay, so and this is big question, how to actually, if you think that a ship is unmanned, how to guarantee that, how keep machine and machinery going on? So this is very big question, this maintenance and service part. Okay, the second box is optimization. This is so important. Of course, there is optimization in many sense. Of course, energy saves all the times, and the route is selected. So navigation is done in such way that energy is consumed as less as possible. And there are a lot of decisions, and autonomous systems can make decisions themselves. That's the point. And then there are those remote and autonomous operations. Okay, there is sensing and actually planning operations, and of course there must be monitoring as well. So as I said, I don't believe in fully autonomous ships. There is always at least remote monitoring and someone who is in the charge of the ship. It cannot be fully autonomous. So maybe in the future, automotive is fully autonomous that way, that no one is monitoring that. But okay, let's see what's happening. Okay, here is the enabling technologies, and Method for robotics is needed, and of course, this application, cloud application, so that systems should be interconnected together, and this communication, cloud services, they are very important. And satellite communication is needed because if you're on the open sea, then that's the only way to communicate. And for example, we have used Iridium satellite communication. It's quite expensive, and bandwidth is quite narrow. So it's not, you cannot send so much situational awareness information through the satellite link. Okay, so that kind of things. And here is development areas. And these are of course valid, if you are making a smart marine, as if you are developing smart marine as well. So that in any case, in order to make a smart system, there must be perception devices, so that which are monitoring essential objects, and of course the radar is the basic instrument, but of course lidars are coming there, and machine vision can be utilized as in Roy's presentation was ready. And then actually there is this operation optimization. It takes, okay, the route should be selected, weather conditions should be selected, and that kind of thing, so that is related to operation. And okay, of course there is a lot of optimization, you see, because there is so much functionality. But here is the health and safety management, and this is related to maintenance and service, how to actually organize that if there are fewer persons in the ship. And communication is very essential in the coastal areas where mobile communication, 4G or 5G are working, then that's the way. And there is a lot of bandwidth in that. But if you are going to open sea, then satellite communication is the only one. And at least currently, actually, it has quite narrow bandwidth what is available. And cybersecurity is very important. And as I said, there will always be, if there is more or less autonomous ships or semi-autonomous ships, there is at least remote control center, and there is some kind of remote captain sitting there, and he's responsible of what's happening to the ship. Okay. Now I'm going to the actually research topics, what we have done, and actually the title was a bit wrong because I'm not telling stories about the whole TKK or Aalto. I'm telling just about what we have done in the automation and systems department, and now actually at ELEC in electrical engineering automation department. Okay, one classical thing is the dynamic positioning, and Jorma Selkän has studied that quite many years ago. We had a project from Finnish Academy, but actually Jorma didn't make his dissertation about this topic. He actually made that, but about robot positioning. But actually here the point is that dynamic positioning system means that the ship should be controlled in such a way that it's in the same pose all the time. And one example is this oil drilling. If ship is used for oil drilling, it must be really in very stable in one position so that drilling is possible. So there must be instrumentation, the position and orientation, and then of course those disturbances should be measured, wind and waves. And actually in that ship what Jorma was studying, there was Azipod type propulsion system. And okay, one thing what is needed is optimal state estimation. So the pose must be estimated, and extended Cannon filter is still very good algorithm for estimating position and pose in general. And then actually in order to keep the ship in certain position, there is control needed, and very efficient way to control is to measure disturbances and compensate that before they are changed to position of the ship. So this kind of feed-forward control is very essential for disturbance compensation, and in ship case there is wind and waves and maybe sea flows as well, which should be compensated. And then of course feedback control is needed for exact positioning always. And actually what Jorma did was later made product for Holming shipyard, and actually Holming sold those ships, so that this was successful project what Jorma did. And actually that modeling knowledge what Jorma developed, we are utilizing that in the tugboat research what we are doing now. Okay, that was one classical example of how control engineering can be applied in the case of ship. And then this second project is very important. You can see it was almost 20, actually it was 20 years ago, quite far away. And this was about how to use LiDARs in the maneuvering of ship. And Jussi Suomela was the responsible manager in this project. It was European Union project, and you can see the consortium here. I'm not going to details, but the point was how to actually utilize LiDARs in actually local or not open sea maneuvering of the ship, but for local maneuvering. And lasers were quite new, and in this project they bought the first LiDAR scanners for our lab at that time. And by the way, this is Jorma Selkähno, this guy. And we utilized later on these Rigel 3D LiDARs in many ways. For example, we utilized them in forest machine research. Okay, but the role for LiDAR is that you can measure distance from short range, and short range means that less than 300 meters, because radars, they are really excellent, but there is this kind of less than 3 meters, which is some kind of blind spot of the traditional radar. And LiDAR is good in that distances. And actually, application area was also studied in this SHICO project, so that inland navigation, short sea shipping, actually this defined later more in detail. And actually here, leaving the port and berthing and clearing the pier and that kind of thing. So that in open sea performance, open sea conditions, the radar is insufficient. So the traditional radar is much better in open sea. Okay, and here is more details about the Rigel scanner, but I'm jumping over, and here is comparison between radar and LiDAR, and the point is that less than 300 meters, actually LiDAR is very, very good, and that is somehow not so good distance for radar. Okay, and here is some examples. So here is bridge, and this is river boat, and it should go through the bridge without colliding to the structures of the bridge. And now LiDAR can be measured for actually, this is real experiment, so that those pots are 3D black dots. They are actually 3D points measured with the LiDAR, and you can see here the measurement angle. And here is another, so that with the LiDAR you can measure those critical structures, so that the ship can be controlled on the basis of that information in a safe way through the bridge area, for example. And okay, that project was 20 years ago, and actually Jussi Suomela is now working in Sim Robotics, so they have actually now utilizing this knowledge also from this project in their operation. In that, so Sim Robotics owns quite a lot of knowledge about how to build semi-autonomous ships. Okay, that was one very good example of the research what has been done in my laboratory. Of course, it was led by that laboratory led by Professor Arne Halme. Arne Halme has retired already a long time. Okay, now I'm going to what we are doing now. And first example is about perception, and ice things related to ice are important in Finland because we had at least earlier real winter, but I hope we will also. But this actually, okay, here actually ice field is measured by using massive vision, and in any case, actually, ships must operate in polar areas and in ship conditions, and this is the purpose to actually measure the ice conditions by using massive vision in this project. And so machine vision cameras are utilized, but also LiDAR here, and Andres Sandur is making his dissertation about this topic. And actually, the goal is to measure actually local ice situation, distribution, concentrations, icy flows, and actually ice thickness has been studied in previous projects already. But of course, ice thickness is also needed if you want to estimate the forces coming from the ice situation. And then later on, Andre will utilize also drones to make more far away analysis of ice situation, and for example, those ice packs are very important to be analyzed, so that in order to select efficient and energy efficient way through those ice packs, you need ice information. Okay, that kind of thing is, that kind of research is done currently by Andrei Sandru, and so this ice field analysis using massive VCN. Second example is actually related to how to operate the ship, how to control the ship, and this is a bit special application. Question is that how to actually move a big ship, for example, cruise ship, using certain amount of tugboats from post A to post B. And actually here we are at first making tool for the captain who's responsible for this moving operation, so that he can plan and monitor how actually the things is going on, and safety must try to be maximized, and of course energy efficient, very important thing. And actually this is application of nonlinear model predictive control, and here the control variables are the propulsion devices of the ship itself. Of course they utilized, but here are the tugboats, 3 tugboats, and they actually make certain force vector, which is then utilized in order the ship can be moved in safe way to actually to the desired position or pose. Okay, so this is the topic of Tero Hänninen, and he's seaman himself. Actually, he's working partly in Alfons Håkans, which is the main tugboat operator in Finland. And then the third example, what we are doing is this coastal bots robot system, and this is diving robot system, and actually this was planned and built originally on the European Union SWAN project for actually measuring local algae blooms in Baltic Sea. But now actually we are building this up again. It consists of several floater types diving robots, and actually they consist of swarm, and okay, there is a lot of interesting topics related to this, and in the next project we will utilize that in the context of defense forces or marine of Finland. Okay. So this was the third topic, what we are doing now. And then here is very important thing, so that Kai Zenger and his group, they are studying how to apply control engineering in actually control the ship diesel in order to get low emissions and the best energy efficiency. And actually there has been already several projects, and more projects will be. So that is very important traditional topic for control engineering, to control the diesel engine in the ship. Okay, that was my last slide.
I think we're just on time. That's all for today. Dear Professor Visala, on behalf of ACAS team, wish you all the best in your future and current projects. And thank you very much once again for your impressive talk today.
Thanks.
Dear audience, thank you very much for joining us tonight. Finally, once again, big applause to Christina, Sarah, and Otto for organizing this event. From my side, Merry Christmas, everyone. Goodbye, everybody.